Hello, and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of triangles. This is standard 6.8a in the great state of Texas, and we are using item number 26 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So this seems like a fairly straightforward problem. We need to make a triangle, and we've got 3 different line segments. This first one is 1.5 inches. And we've got 2.5 inches. So the trick here is we need to use a ruler, or if you were taking this paper pencil, to measure the length of this third line segment to the nearest ½ inch. Well, since it's on a screen, we can't do that, but I'll go ahead and give you the measurement. It is 4.5 inches. So we need to make a triangle with these 3 line segments, and we need to figure out which one of these statements is correct. So let's take a look at what this triangle would look like. So let's pretend this 4.5 inches here. Let's just pretend that is the base. So I'm just going to kind of put that right here. Make it a little bit bigger so we can play with it some. 4.5 inches. I'm going to connect my 1.5 inches right here. I'm going to make it a really thin triangle with maybe like an obtuse angle up on top. So I'm going to call this 1.5 inches. And then I'm going to call this 2.5 inches. And I think I might have found the problem. I kind of estimated my 1.5 and my 2.5 inches, and they don't quite touch. Let's see what happens if I actually add 1.5 and 2.5. So 1.5 plus 2.5, well, let's see, this 1/2 and 1/2, that's going to make 2 halves. 1 and 2 make 3, so it's 3 and 2 halves. So 3 and 2 halves, that's 3 and an extra 1. So that's just going to make 4. So guess what? If I put this and this together, it's 4 inches. Here's the problem. My base is 4.5 inches. So even if I laid these two flat down on the base, had a 0 angle or maybe a 1 degree angle that was just almost looked like it was flat, I'd still be a ½ inch short. So I don't have 3 line segments that can actually form a triangle because these 2 little arms here, the 1.5 and 2.5, are too short. So let's look at our answer selections. Which of these statements is true? F. These line segments can form a triangle because each side of the triangle can be a different length. Well, each side can be a different length. That's fine. That's called a scalene triangle. And we do definitely have 3 different side lengths. But I'm not sure that they can form a triangle because I'm a ½ inch short. But I can definitely see how this might be the most selected incorrect answer. G. These line segments can form a triangle because the longest side of the triangle can be exactly 4 inches long. Well, these line segments could almost form a triangle, but the longest side is not 4 inches, it's 4.5 inches. But even if it was 4 inches long, it wouldn't be able to form a triangle. I wouldn't be able to have any angles. It would have to be a straight line, because here would be my 4 inches. And then I would just have to put my 1.5 and my 2.5 right on top of it, and I couldn't have any type of angle right there. So that's not even a triangle. The more that you raise up these arms right here, the more that they start coming back a little bit, and you need a longer arm. As you open it up, it starts coming back. So that's not going to work. H. These line segments cannot form a triangle. There we go. Because at least 2 sides of a triangle must be the same length. No. That's an isosceles triangle. We are fine with this being a scalene triangle. That is incorrect. J. These line segments cannot form a triangle because the longest side of the triangle must be shorter than 4 inches. There we go. We've got to be shorter than 4 inches, so our answer is J.